Hi guys, welcome to Piece of Code and welcome to this video. In this video we're going to cover the most important topic in AWS, which is VPCs, which is virtual private networks. Why is it the most important topic in AWS? In my opinion is that, to make your device communicate with each other, right, you have to put it in a network, right? It can be a local area network like a LAN network, or you have to associate it with a public IP address. Somehow it has to be in a network, right? Otherwise it will be isolated from the outside world, and that kind of device is of no use. So like if you are owning a own data center, you have to create a LAN, which is a network, local area network, and you have to like configure each device manually, like switches, routers, and so on and so on. But if you are opting for a cloud model like in AWS, you can create the network on the cloud, right? You don't have to configure anything. You just have to click some few buttons, and you have just to have a little bit knowledge about networking, and you are good to go, right? So without wasting any time, let us dig deep into this topic. And yes, this is going to be a little bit of longer video, so please bear with me, because we're going to cover each and every nook and cranny of this VPC, and you will be the master of VPC after this video. I'm gonna have full confidence in that. Okay, let us move on. So first of all, this diagram should be like spider web for you, but as we progress through this lecture, it will be like a piece of cake, right? For now, you can keep a screenshot of it like a reference. I'm not gonna explain anything in this particular diagram. We're gonna explore each and every part in a sequence, and it will be better for you in that manner. All right, let us move on. First of all, before going into VPCs, subnets, networks and everything, you need to understand what is a subnet mask, because if you do not understand what is a subnet mask, then you will be having problems while creating your own VPC and subnets. So a subnet mask basically allows part of the underlying IP to get additional next values from the base IP. It just means that if you have a network, how many devices can you create in that network? Are you going to keep 50 devices? Are you going to keep 100 or 200? It devices on the it depends on the subnet mask, like how many devices is going to be in that particular network. Let us see how it actually happens, how the subnet mask is calculated. So we have this particular, for example, this example. So this is a common IP address, for example 192.168.0.0, and then we have a /32 over here, and this is where it becomes interesting. It says it allows for only one IP, and it says 2 power 0. The thing is, subnet mask, you have to write it like /16 and /32 or /18, whatever. The thing is, in an IPv4 address, it consists of 32 bits, right? It is an IPv4 address, right? So each part that you see over here consists of 8 bits, right? So if I say /32 over here, it just means that there is no place for any IP address, like it's just one IP address, because we are not leaving place for any bits over there. That's what it means. So if it is 32, the easiest way to calculate the number of devices is just 32 minus 32, which is 0, right? So you're gonna just do 2 power 0, which is one device. That's what it means. As I told you, right, each part is kind of 8 bits, so we can also say it as an octet. So first part, second part, third part, and the fourth part. So in /32, as I've told you, right, 32 means that there is no bits free kind of thing, so no octet can change. If it is a /24, the last octet can change. If it is a /16, 2 octet can change. /8, 3 and 0, all octets can change. So it simply means that if there is a, for example, a /31 over here, you just have to do 32 minus 31. Just follow this formula. It's a very cool formula, and you will get 1, right? And just do 2 power 1. So how many addresses you're gonna get? You're gonna get 2 addresses, because 2 power 1 is 2, right? So up to this. Similarly, for /16, for example, you're gonna get 2 power 16 addresses, because 32 minus 16 is 16. So you're gonna get 2 power 16, which is 65,536 IP addresses. So the number of devices corresponds to the number of IP addresses that you're gonna have in your particular network or in your subnet, right? And basically /0 practically means the whole internet, obviously, because you're not leaving anything out. You're gonna occupy all the octets or all the bits, right? So it just means that it is the whole internet. I hope that makes sense. And the understanding of subnet mask is very, very important while creating a subnet. Okay, I hope that makes sense. Let us move on to the next slide. Now, publics versus private IP, guys. Now, the Internet Assigned Numbers Authority (INA) established certain blocks of IPv4 addresses for use of private or LAN networks and public internet addresses. So it means that there are certain ranges of IP addresses that you can use in your networks, like in your LAN or in your VPCs, and others are kind of reserved for other purposes. So I have mentioned over here what you can use where, so it should make a lot of sense over here. So a private IP can only allow certain values. So if you're gonna go with like the 10.0.0.0 to 10.255.255.255, they are for big networks, and it can be a private IP because the private IP can be within these three ranges. But if you're gonna go with the 10.0.0.0 to 10.255.255.255, then it is a big networks. And as you can see here, 3 octets are changing. That's why the subnet mask over here is a /8. 3 octets means how much? 24. So 32 minus 24 is 8. So it's a /8 over here, right? So that's what we how you're going to calculate the subnet mask. I hope that is making sense. If it is not making sense over here, just go back to the previous slide and just have a good look into it. Now let us go to the second part over here. So 172.16.0.0 to 172.31.250.255. This is actually AWS's default VPC. Now a default VPC in AWS is nothing but a default VPC. So when you create an account, AWS is such a good guy that it just generates a VPC for you, because if you go and watch my other videos, I haven't created any VPC over there. I just randomly went and created all those EC2 instances, all those services over there. So where do those services are getting created? It is getting created in the default VPC, because if there is no network, as I've told you, right, your devices cannot communicate with each other or with the outside world. So how does it happen? Because of the default VPC. We're going to explore the default VPC in a minute, so don't worry about it. Now these are for home networks, which are basically your home routers and stuff. So I hope you can remember these private IPs. You can actually use any of these ranges in your VPCs also, so don't worry about it. Actually, this is a very big range, and you can use, like, create how many networks you want. Only thing you need to keep in mind that your network shouldn't overlap with each other, that you shouldn't have IP ranges in your network which are overlapping. That is not allowed, okay? And it should make a lot of sense. All rest of the IP address are public, right? So if you are gonna, that's a public pool, so whenever a new device goes into the public, like the public internet connects to it, one of those IP addresses are assigned to here, to that particular device, like a mobile. Okay, so what is a default VPC on AWS? As I've told you that all the new accounts that you see, okay, just a minute, all new AWS account have a default VPC. So new EC2 instances are launched into the default VPC if no subnet is specified. Like, I've done it numerous times while creating EC2 instances, while creating load balancers and all. I used to do it in my default VPC. All right, default VPC has an internet connectivity, and all EC2 instances inside it have public IPv4 addresses, and it is a default property of the default VPC. It is being set automatically, but it is up to you if you want to allow public IP addresses in your VPC, and there is a setting which you can, where you can go and enable that. So we're gonna see it in a minute, so don't worry about it. We also get a public and private IPv4 DNS names, right? And it is done automatically while you create an EC2 instance. If you mark, you're not gonna yes, you always get that particular DNS endpoint, right, from where you can reach your EC2 instance. Alright, so let us explore that default VPC that I was talking about. So let us just go over here and search for VPC over here, and just click on this VPCs, and we're gonna have a VPC that is our default VPC, and it is here over here. So it has a state that is available obviously, and we have IPv4 CIDR, which is /16 subnet mask. It just means that it can have up to 2 power 16 IP addresses, like 32 minus 16 is 16, so 2 power 16 is 65,536 IP addresses. I hope that makes sense. There are a lot of things that is associated with our default VPC, and we're going to configure everything with our own VPC. Don't panic and don't worry about it. The important things to see is the main route table that is being associated with this VPC. Route table is nothing but all the routes that you're going to declare in your particular VPC. So for example, one EC2 instance over in this subnet needs to communicate to another subnet, to another EC2 instance. So you need to establish a route over there. So that's an example. You can create multiple routes, doesn't matter. It has a main network ACL. ACL is nothing but access control list. It's just like a firewall, right? And you can create multiple ACL, so don't worry about it. And it's a default VPC, which is yes, and there's a owner ID over it, right? So you can see a lot of stuff over here, and it's pretty cool, right? And these are all the CIDRs. You can also go to the subnets. So we should be having like you can do a filter operation over here. You can, if you have multiple VPCs, so it will be like cumbersome to search for your subnet. So if you go over here and just select, now we only have one VPC, so it doesn't make any sense to use this filter, but still it's a good feature that I'm going to use a lot, so I'm just going to let you know. So currently it has 6 subnets. I'm going to tell you what subnets are. It's just like a group of it's kind of a small network inside your network, that's it. And actually, if you see, VPCs are regional in nature, so you can create the subnets in a particular region in various availability zones. So if you have a look over here, so it by default creates subnets in all of the availability zones in this US East 1 region. So there are 6 availability zones, so 6 subnets are there. Alright, so here it's a default subnet. Yes, it has a network ACL, which is the same network ACL associated with all the subnets. And here you can see this is the option which says that every device in that particular network will have public IP address. As it is by default says yes, so you can assign public IP addresses to your devices in the default network. I hope that makes sense. So auto assign customer owned IPv4 address, just that like if you own an IP address, if you wanna assign to a device, then it is by default no, but you can enable it and you can assign it if you want. And IPv6 is also not enabled by default. If you want to assign IPv6 to your devices, you can assign them by enabling this option. If I go to route tables, I hope there will be one route table, and if you have a look at this route table, the routes, the destination is first of all 0.0.0.0/0. It means that basically there is an internet gateway. Internet gateway is just a gateway towards the internet. So each device has a route out to the internet. Just means that it has a route out to the internet through the internet gateway. That's what it means. And every device in the network can communicate with each other, and that's a local target. Obviously, like it should be like a common feature that all the devices in your network should be able to communicate with each other. Don't panic over all these things. I'm just giving you a summary of what are the devices in a network. Then there is a one internet gateway. Obviously, internet gateways are used for a route out towards the internet. If your devices wants to communicate to the internet, you should have an internet gateway. Then there is an egress only internet gateways. It's for IPv6. As we don't have IPv6, there are no egress only internet gateways. So a lot of other features like elastic IPs, which is basically going to buy or purchase an IP address, and it should be over here. Then there are endpoints. We're going to discuss what endpoints are later on. There are NAT gateways. What are NAT gateways? I'm also going to discuss about that. And there are also something known as peering connections, but now we don't have anything. In case of firewalls, we have security, we have network ACLs and security groups. You already know about security groups if you have watched my EC2 video and all separate other videos. I've used security groups like everywhere. Then a lot of stuff is there. Not gonna explore all of those options. You're gonna get confused a lot. Okay, so this is how you're gonna explore your default VPC. I hope that makes sense. All right, now let us move on and create our own VPC, right? Let us talk about VPCs in AWS in general. So VPC is a virtual private cloud. I hope that is clear till now. I hope you don't have any doubts in the VPCs, like what is the full form of VPC. You can have multiple VPCs in a AWS region, max 5 per region. It means that per region, like in for example, sorry, I just dropped my pen. For example, in US East 1, you can have up to 5 VPCs. So, but it's a soft limit. It means that you can increase that limit by contacting the support or something like that. So max CIDR per VPC is 5. It means that you can have up to 5 CIDR ranges in your VPC. Cannot have like 10 CIDR ranges, like a /16, then /8, then /12 and something like that. You can go up to 100. It's not possible like this over here. You can have up to 5. Minimum size of your VPC is /28, which basically is 2 power 4 IP addresses. Minimum you should have minimum of 16 IP addresses. Maximum you can have up to 2 power 16, which is 65,536 IP addresses. So you should keep this in mind and do not exceed these limits, guys. And there is a reason for that. If you wanna keep only 10 devices, that makes no sense to create a network over in the cloud. So that's why the least number of IP addresses is 16 over here. And if you're gonna create such a large VPC that's more than 65,536, it is going to be hard to manage. So it makes sense. I can understand these limits. You should also remember this thing. Because VPC is private, only the private IPv4 ranges are allowed. Obviously, we have already discussed that you have to create your VPCs and they should have CIDRs in these ranges, right? Do not exceed, create other ranges, because it will not take actually, because those are public IP addresses. Another very important, I've already noted this thing before, your VPC CIDR should not overlap with your other networks, right? Even if there is a corporate network, that is your own data center, and it is it has a connection to your cloud VPC or AWS VPC, and there are other features how you can have a connection between your cloud, your data center and your cloud. There are options to do that. We're going to discuss that later on, like in the last part of the lecture. Even if this is the case, you cannot have overlapping subnets, subnet masks between this one and this one. Overlapping IP ranges are not allowed over here. So make sure you follow this rule from head to toe. Okay, that makes sense. Let us go over and create our first VPC. So this is just a simple diagram. So we have a region, for example, this is US East 1, and we're going to create a VPC over here, and we're going to name it as prod VPC, right? And after that, we're going to add one component as we go on in our particular journey, right? I'm going to keep it simple and keep it interesting. Not going to create everything at once, because it will be a lot more difficult for you guys to understand. So I'm going to go over here. I'm going to just click on create VPC, and it's very easy to create a network on AWS. I'm just going to say prod VPC, and I will be having a IPv4 CIDR block, and the IPv4 CIDR range that I'm going to keep is, let us keep like 10.0.0.0. Let us take the maximum, which is /16, right? We're going to have 65,536 devices over here. We're not going to keep the IPv6 feature for now, and you can just gonna click on create VPC. That's how easy it is to create a VPC. And if I go back right now to my VPCs, to like in your VPCs, I should be seeing my prod VPC over here. And if you want to filter out, it is very easy. Just select it, and you're gonna see your VPC, just the one entry over here. So currently, if you see your VPC, it is just a basic VPC, and it is associated with the main route table. We are going to create our own route table, don't worry. It is associated with the main network ACL. Tenancy is default. It is not the default VPC, and it doesn't have currently any subnets and stuff, and everything is like default over here. So we're going to make some changes later on, right? So that's how you create a VPC, guys. Very easy. Let us move on to the next point, which is adding subnets. Alright guys, we just created our VPC right now, and we're gonna now talk about the subnets. Now first of all, you need to keep in mind before talking about subnets is that AWS reserves 5 IP addresses, which is the first 4 and last one in each subnet. These 5 IP addresses are not available for use and can't be assigned to an EC2 instance. And for example, if a CIDR block 10.0.0.0/24, it means that there will be 256 IP addresses. 2 power 8 is 256. Then the reserved IP addresses are the first 4, which starts from 0, 1, 2, 3, and then the last one, which is .255. So if you, for more details, the .01 is the network address. The .1 is for the VPC router, because the router is also a device and it also requires an IP address. .2 is reserved by AWS for mapping to Amazon provided DNS, right? And .3 is for AWS for future use. It just kept like that, this reserved. And 255 is a broadcast address, right? It is a broadcast address, and AWS does not support broadcast in a VPC. Therefore, the address is reserved, because you cannot broadcast to all of the devices in a AWS VPC. That is not possible in this case. That is why you cannot use that particular address. But in general, this is a broadcast address. So an exam tip before going into the subnet thing: if you need 29 IP addresses for your EC2 instances, then if you take a /27 subnet mask, you're gonna get how much? 2 power 5, that will be 32 IP addresses. But in that 32 IP addresses, -5 we need to do, because those 5 addresses are reserved. So you're gonna get 27, which is less than 29. So it is a wrong answer in this case. So you need to go a bit beyond that. So if you go /26, you're gonna get 64 IP addresses. So the number of IP addresses which we're gonna get for the EC2 instances is 59, which is good in this case. It's a correct answer. So subnets in general are nothing but it's kind of a logical differentiation of different groups of devices in your network, right? For example, you have you have web servers which will be public facing, and you're gonna have database server which is going to be like private facing. So to differentiate this, so you just want to assign public IP addresses to your web servers, and you're gonna assign only private IP addresses to your database servers. To do that, you can create a public subnet and a private subnet. It doesn't mean that you have to create every time you have to create one public subnet and one private subnet. You can have any number of subnets. It's up to you. But the thing is, this is how it is very useful, right? You're gonna keep all of your web servers in a public subnet, and you're gonna keep all your database servers in a private subnet. So that's how subnets actually mean. And keep in mind that subnets will also have their own CIDR ranges, and it should be inside the CIDR range of your VPC CIDR range. Keep that in mind. It doesn't mean that you're gonna create a VPC like in a 172 range and you're gonna create a subnet in the 10.0 range. That is not possible. So make sure you keep that in your mind, right? If your VPC supports 65,536 IP addresses, your subnets cannot be bigger than that, obviously, because the maximum capacity of your network is that much only, right? So it should make a lot of sense in this case. Alright, now let us move on and create our subnets, and after that we're going to go into internet gateways. Let us create our subnets first. Before going into there, this is a very cool website that I find very useful actually, ipaddressguide.com, and if you have any confusions regarding your CIDR range to IP range, you can use this website. For example, if you wanna go with this CIDR range, you can just click on calculate, and it should tell you the first IP and the last IP in your range. Total number of hosts in this case is 256, and this is the CIDR range. Should make sense. So you can use this if you are confused, and at first people get confused. So it's natural, so don't worry about it. You can use this website for a clearer view. Let us go into a VPC console. Let us go to subnets. Currently, if you see, all of these subnets that we have is associated with our default VPC, but we don't want that. We're gonna create our own VPC. So if I filter by my VPC, which is this prod VPC I just created, I just have no subnets, obviously. And if I see this diagram that I will create two subnets. One public subnet which will contain my devices, which will be like public facing to the internet, and I'll be having another private subnet which is gonna be like private. It's only going to have private IP addresses. So for now I'm going to create two subnets, and don't worry about the functionalities. We're going to add those functionalities later on. For now, let us create two subnets. So let us create subnet. and the VPC we're going to create is in this prod VPC. You're going to select that. So the IP for CIDRs is already written over here, so for your reference. Okay, so I'm going to add one subnet over here, and I'm going to name this as public subnet, and the availability zone I'm going to select as US East 1A. Let us keep it in the same availability zone, and the IPv4 CIDR block for this, let us take 10.0.0.0/24. So you can understand how many devices is going to be in this particular CIDR block, and if you have issues, you can just go into this particular website and check. So I have taken this block, and it has like 256 IP addresses. So the number of EC2 instances or devices that can be in my subnet is 251, because you minus 5 IP addresses. Alright, that makes sense. Now let us add our private subnet. So I'm just gonna say add new subnet, and we're gonna give the subnet name as private subnet, and the availability zone I'm gonna keep in US East 1B. So I'm gonna select that, and we have to provide the CIDR block. And if you see, we had taken this CIDR block, and the last IP address in the CIDR block was what? Sorry, got changed, 0.0.0.0/24. Okay, so the last IP address over here was .255, right? And the next IP address that we're gonna take, the next range I'm gonna take is .0.1.0, because if you're gonna take 10.0.0.1/24, then it is going to overlap with this particular IP address, and we do not want that. It is going to overlap with this particular range, right? Because if this last octet, with this last octet we are creating this public subnet, and if you're going to use the same octet for the private subnet, and it's going to be a problem over there. So we're going to use the next valid IP address range, which is going to be, in our case, 10.0.1.0/24. Now you can take any other valid IP address range. I don't care. I'm just taking it so that we're gonna keep things simple, so that I'm taking the next valid IP address range over here. Okay. Now we're gonna just click on create the subnet now. So it should create two subnets. One will be the public subnet, and we're gonna create a private subnet over here. Don't worry about the functionalities, guys. We're gonna discuss about the functionalities and create those functionalities for those subnets later on. Don't worry. And we have successfully created our two subnets. Let us move on to the next topic. Okay, so let us talk about this internet gateway and why it is important, right? So it allows the resources, for example, which are EC2 instances, basically in a VPC subnet, in a VPC, to connect to the internet, right? So basically you have EC2 instance in your VPC, which is in a subnet. If it needs to communicate with the public internet, then it needs to go through a internet gateway, IGW, right? It scales horizontally, and it's highly available and redundant. It must be created separately from a VPC. It doesn't come with a VPC. You have to create it and attach it to a VPC. It must be done manually. One VPC can only be attached to one IGW and vice versa. So if you have one VPC, only one IGW must be there, and it makes sense because there should be only one point of contact, to the outside world, right? Internet gateways on their own do not allow internet access. Route tables must also be edited. Now we're gonna see this in action in a minute, so don't worry about it. Okay, so we're gonna add an internet gateway to our previous, what we have created over here. We have created a public subnet and a private subnet, and we're gonna add an internet gateway to it, and let us see, right? And then what we're gonna do, we're gonna edit the route tables so that if there is an instance, there will be route established to the internet. Otherwise, the instance will not be able to communicate with the internet, even though there is an internet gateway, right? We have to create a route out to the internet. All right, let us do this right now, and let us create those things. So currently we have this prod VPC, and in this prod VPC, if I just filter by my prod VPC, we have two subnets. One is the public subnet and one is the private subnet, right? So what I'm gonna do right now is I'm gonna go to the EC2 console and create one EC2 instance in my public subnet, right? So I'm gonna try to communicate with the outside world using my EC2 instance, and I'm gonna deploy that instance in my public subnet. All right. So I'm gonna go and launch an instance over here, and I'm gonna just name this instance as, for example, public server, something like that, and everything will be the same. In the key pair, currently I do not need a key pair. Proceed without a key pair. Let's go with that. And over here, like for security groups, I'm just gonna say, okay, select an existing security group, and we have this launch wizard 1 security group. I'm gonna select that. It has all the required accesses. And for the network settings, I'm gonna just choose my VPC, this prod VPC, instead of the default VPC. And in the subnets, I'm gonna choose the public subnet. Now if you see, this auto assign public IP is disabled by default, and there is a reason for that. Because if I go back to my VPC management console and go to my public subnet, and if I see over here somewhere auto assign, where is that, auto assign public IPv4 addresses, it says no. So by default, if you create something in this VPC, it will not be assigned any public IP addresses by default. So we need to change this particular property, and I'm gonna just say edit subnet settings, and I'm just gonna go over here and just check this auto assign public IPv4 addresses and click on save. Now if I create something in my public subnet, this particular subnet, then automatically if I choose assign a public IP addresses, the device will get a public IP addresses in that subnet, and it should be enabled in your public subnet, because your public subnet will be the public facing devices, right? It will contain all of those web servers which will be public facing. You don't have to do this in your private subnet, because private subnets do not need to have any public IP addresses. I hope that makes sense. Alright, so if I go back over here, I will be able to assign the public IP addresses to my instance, and I think this should be okay. It says that the selected security group is not compatible with the subnet specified. Please specify a security group that is in the same VPC as your subnet. So it means that it says that this security group is not present in my VPC. So basically it is from the default VPC, so it will not gonna work. So your security group, it should be associated with your VPC that you are selecting over here. So to make things simple, I'm just gonna go and create a security group, and I'm name this security group as my public EC2 SG, so that I'll be able to differentiate this security group. And in the description, I'm just gonna say for EC2 instances in the public subnet. Okay, that should make sense. And for now, I'm gonna allow SSH connections from anywhere. So I'm gonna keep this as over here. And for network interfaces, just leave it not needed as of now. In advanced details, gonna just keep everything simple, and we also do not need anything in the user data section. All right, now I'm just gonna click on launch this instance. So it has been launched. If I go to my instances right now, so the instance state is in pending state. It will take some time to launch. Okay, let's wait for that time. Alright, so it is in running state, and if I just select this particular instance and I go like, let's say I want to connect to this instance, I'm going to click on connect. So I have allowed SSH connections into my security group, so I should be able to communicate with this instance. So I'm just going to click on connect over here. I hope I will be able to connect to it, but let's see. But yeah, interesting. It says failed to connect to instance. EC2 instance connect is unable to connect to instance. Ensure your instance network settings are configured correctly for this EC2 instance connect. So it is not able to communicate with my EC2 instance. Why is that? The simple reason is that our VPC doesn't have an internet gateway, so it doesn't have a route from the outside world or to the outside world. So we need to create a internet gateway so that anyone like outside the world will be able to access your EC2 instance, even though the security group allows it. But the first thing is that your VPC must allow it through the internet gateway. If it is isolated from the outside world, then how will the traffic from the outside world reach your instance? That makes sense, right? Now we're gonna go to our VPC management console, and we're gonna go to internet gateways, and if I search for this prod VPC, currently we do not have any internet gateway associated to it, and if I remove the filters, then one internet gateway is associated with the default VPC. I hope that makes sense. For the new VPC that we have created, we're gonna create a internet gateway. Gonna name this internet gateway as my prod VPC IG, something like that. So I'm gonna create the internet gateway. That's how simple it is to create the internet gateway. And if you see the state, it is in detached state. It means that we need to attach it to a VPC so that then it will be able to associate it with the particular VPC. So we're gonna click on actions over here and attach to a VPC, and we're gonna select a VPC which is the prod VPC and attach internet gateway. So it is in attached state. So now I hope that I'll be able to communicate with my instance. So if I click on connect right now, now the internet gateway has also been associated to it. So it should connect, right? Let us see. Still it says failed connect to a instance. Now what is the reason? Interesting. We created an internet gateway, and it provides you like the VPC can communicate with the outside world, but what is the reason that we are still not able to communicate? The reason is pretty simple. Even though we have a door, let me give you an example. So basically you have a big house, right? And you have a door, and you are present over here. You are new to this house, right? And basically you know that the door exists, but you do not know the route to the door. So someone needs to tell you, okay, you need to follow this path to reach the door. That is know the route. So this is where the route table comes into the picture. So you need to establish a route to the internet gateway so that your EC2 instances will know, okay, so this is the route to reach to the public internet through the internet gateway. So we need to edit the route table in this particular case. I hope that makes sense. I know that's a lame example that I gave you, but it should make sense right now why the route tables are important. So I'm going to go to the route tables, and if you have a look on this route table, so currently we have two actually route tables, and if I select this VPC, prod VPC, then I have a route table associated with this prod VPC, and this is known as the main route table. It means that when you create a VPC, a main route table is created for a VPC. So you can create your routes in this particular main route table. Now the thing is, this main route table is not associated with any subnets. It doesn't have any explicit subnet association, but it is a main route table. You can add those subnet associations. You can associate a subnets with the main route table, and then you can associate the routes to it, right? But the thing is, I don't like this particular format. What I like to keep is, I like to keep things segregated. What do I mean by that? If I have public routes, it should be in the public route table. I don't want to mess with the private routes and the public routes and keep it all messed up at one place. If I have public routes, it should be in a separate route table, and if I have private routes, I should be in a separate route table. So what does that mean? For every subnet, I want to create a separate route table so that they are segregated from each other. The routes do not overlap with each other. That's what I mean. So what I'm going to do over now is, I'm going to ignore this main route table. Instead of that, I'm going to create my own route tables for my subnets. So I'm going to create a route table, and I'm going to name this route table as public routes, and I'm going to select a VPC, that is my prod VPC, and I'm going to create this route table. Similarly, I'm gonna go into my route tables and create another route tables, and I'm gonna name this route table as private routes for my private that is subnet, something like that. And the VPC is basically prod VPC. You can create as much route tables as you want. If I go to route tables now and if I select my prod VPC, I should be seeing 3 route tables now. One is the public routes and one is the private routes. Let's have a look at this public routes route table. And if I see, currently it is not associated with any subnets or whatsoever. And if I see the routes over here, it says that if any route or any IP address that is in this particular CIDR range, then the target is local. It means that any instance in your VPC will be able to communicate with each other because it's the same network. That's what it means. But apart from this particular route, I want to establish another route which will be to the internet gateway, so that any IP address coming apart from this particular IP address should go through the internet gateway, right? Because this instance has a public IP address, right? If I go to instances, this public server has a public IP address which is different from this particular range. So if that particular IP address is the destination, it means that it needs to communicate through the internet gateway. So I need to create another route for that, right? All right, so let us do that and let us edit our routes. So to edit the routes, you can just click on edit routes over here, and you can just click on add a route, and we're gonna say any other IP address except this particular IP address, any other IP address. The target must be the internet gateway, and here we have this my prod internet gateway, and we're gonna select that, and we're gonna save the changes. Now the routes have been established, but the subnet associations has not been done. So for this public routes, I want it to be associated with the public subnets only. If you have a bunch of public subnets, I want to associate those public subnets with this public routes route table, right? Because that needs to be communicated with the outside world. And for other private subnets, if there are specific routes that I want to configure, I'm going to configure that with the private route table. I hope that makes sense. Now, if I go to subnet associations, I'm going to say edit subnet associations, and I'm going to add this public subnet to my public routes route table, right? I'm going to select this, and I'm going to, save this associations. I'm just going to select this and say save associations. And if I check now in subnet associations, this particular route table, which is the public route table, is associated with the public subnet. That is cool, great. Let's go back to our route tables and do the same thing for the private routes. Let me just select the prod VPC over here. Why it's not coming? Okay, so we have these things. So let us go to the private routes now. And if I go to subnet associations, let us edit the subnet associations for this private routes and add this private subnets to our private routes route table. Save the associations. Great. Now we are done. So if I select my prod VPC, and we have 3 route tables. One is the main one. We're not gonna touch it. We have the private routes and we have the public routes. And in the public routes, in the subnet associations, we have one subnet which is public subnet, and also if I go to our routes, we have 2 routes. One is the local route and another one is the route out to the internet. Sorry, this is the route out to the internet and this is the local routes. And the target, you can see, that is the IGW. I hope that makes sense. And in the private routes, if you see, we have our routes, which is the local route. I don't want the private subnet to communicate with the internet, so we do not have a route out to the internet. And in the subnet associations, we have this private subnet over here. Great, that makes sense, right? Now I think we are done. Now I think if I go to my instance and if I want to connect to my instance, as this instance is in the public subnet and my public subnet has a route out to the internet, and the security group also allows SSH connections, I think we are good to connect with this particular EC2 instance. Let us click on connect over here. See, now we are able to communicate with our EC2 instance. I hope now you understood what is the importance of internet gateways and route table, actually not in just the VPC like in the AWS internet, but also in normal scenarios where you create a LAN or a local area network in your data center. You need to configure these devices, otherwise it is not gonna work. Alright, I hope that makes sense. Now let us move on to the next topic without wasting any much time. So we edited a route table. So that is the second step we have done, and we added the internet gateway. Let us move on and let us talk about Bastion hosts. So what is a Bastion host? It's just a simple thing to understand that you have a bunch of private instances in your private subnet, and this private subnet doesn't have the route out to the internet. It is not able to communicate with the outside world. But the thing is, you still need to connect to your private subnet. How do you do that? Because your private subnet is not associated with the outside world, so this private instances will not allow direct SSH connections to itself, right? So what you need to do is you need to create another instance in the public subnet. So basically, if you create it in the public subnet, outside users will be able to access that instance, right? And if this instance is in the same VPC, in the same network as this private instances, this instance in turn will be able to communicate with your private instances, and that particular type of instance is known as a Bastion host. What are the advantages of the Bastion host? Basically, you want to run some patches or some OS updates on this private instance, or you want to do some updates directly on these instances, or need to specifically connect to a backend, private instance. So the Bastion instance will come in very much handy. Very important things to remember: the Bastion host security group must allow inbound from the internet, because obviously your users should be able to reach your Bastion host, and the security group of these private instances must allow incoming SSH connection from this Bastion host. I hope that makes sense. And we have talked a lot about security groups in my EC2 lecture. If you have some doubts about security groups, please watch that. But in simple terms, a security group is a firewall of your EC2 instance, right? So if you have a EC2 instance, this is the security group SG, and it is a stateful firewall. So it means that if you allow certain incoming connection, for example SSH, then by default outgoing is also enabled. So this is the last kind of phase of firewall for your EC2 instances. And if you don't allow like SSH connection, even if you have a public subnet, the EC2 instance will not take any SSH connections or any HTTP connections based on your rules. I hope that makes sense. So I hope you understand what Bastion hosts are. And basically there is an instance, the public subnet, and it will contact your private instances on your behalf, and you can do the SSH from that Bastion host. Alright, I hope that makes sense. Let us do a little bit of demo on this Bastion host now. So I'm gonna go to my instances, and I'm gonna create a private instance now. A private instance is nothing but an instance in our private subnet. It will not have any public IP addresses, or we cannot directly connect to our private instance. We're gonna launch our instance in a private subnet. That's what I mean. So I'm gonna name it as my private server, and we need the Amazon Linux. And here in the key pair, I'm gonna create a key pair, because if I want to SSH into this instance, I have to do it from my Bastion host, and I need the key pair for that. So I'm gonna just say let's select a key pair. I'm gonna create a new key pair, that will be better, and the key pair name is my private key pair, and we need the .pem file. So let's keep it that for the key pair, and let's create the key pair. Here is my PEM file, and in network settings we're gonna edit this network settings, and we're gonna select our prod VPC from here, and in the subnet I'm gonna select the private subnet. Okay, and in the firewall or security group, I'm gonna create a new security group, and I'm just gonna say private EC2 SG. And here I'm gonna create a rule which says SSH, incoming SSH connections, and the source type is not anywhere. Instead of that, I'm gonna give a custom source type, and the source type will be a security group from the public SG, which is my Bastion Hosts public security group. So it will only allow the connections from the Bastion Host security group. That's what I mean. And I think that must be it for the network settings. And if you see, auto assign public IP is disabled by default because it's a private instance. It will be in my private subnet. And I think that must be it. And we can launch the instance right now. Okay, so while this instance is launching, I'm gonna pause the video for a minute and then I'm gonna resume it. Okay. Okay guys, so our private server is up and running. If I see this thing, it doesn't have a public IPv4 address, and it only has a private IPv4 address here. And if you see, the settings are like a normal EC2 instance, and I've renamed the public server to the Bastion host so that you'll understand, okay, this is the Bastion host. I haven't created a separate public instance for a Bastion host, so I've just renamed that public server as the Bastion host. All right, so they're up and running. That's cool. So what I'll do is I'll try to connect from this Bastion host to this private server. I'll try to establish SSH connection from this Bastion host to the private server, right? I have all the network settings in place, so it should work fine. So I'm just gonna say connect, and I'm just gonna connect to my Bastion host using EC2 instance connect, and we are here over. Okay, so I'm here. First of all, I need the PM file or the key pair file, right? So I'm just gonna go over here, and I should be having that my private key pair. I'm just gonna open it up in Notepad++, and this is the key pair file. I'm gonna copy everything from here because I need this key pair, right, to communicate with my EC2 instance, and I'm gonna create a new key pair file over here, and I'm just gonna say vi demo. I'm just gonna say key pair, okay, .pem, because this is very important that you create an key pair file with .pem extension. And here we are. Let me click on insert, and let me just, okay, it is not getting copied over here. How do I copy it? Okay, so welcome back guys. So basically I had to change my browser to Microsoft Edge, because in this browser I was not able to copy paste the particular things. I don't know, it's something with the browser, but in the Edge browser I was able to copy and paste that particular key. That was my private key pair, and this is the key pair over here, and I've pasted it. So I'm gonna save my file by just doing :wq, and it should be fine. And I've also renamed it to my demo key pair to my key pair.pem. I hope that makes sense right now. Okay, so what I did, I just created the key pair file over here, copy it from the downloaded key pair from my desktop, and here I have just edited it and pasted that key pair over here. And if I do a cat my key pair.pem, then you can see that I think it is fine. Right, so we are ready to do a SSH connections right now. I'm just gonna clear the screen, and we're gonna first of all give the permissions of execution for the key pair file. So I'm just gonna do chmod, otherwise it will not run. We have to give read write permissions by ourselves, and I think it will not work. So I'm just gonna use a sudo chmod, and I'm gonna just say 0400, or you can also give 777, and you are giving full read write and other permissions at once. So 777, and then you can just specify my key pair.pem. So now it is done. Now we are going to SSH into our SSH, right? And you have to use our the private IP address of our EC2 instance, this private server. So I'm just going to select it and select the private IP4 address, and I have to go back over here and SSH. I'm just going to say EC2 -user, right, and @ I'm gonna paste this private IP4 address of my private server, and let us give or pass in our key pair file, otherwise it will not connect to it. -i, and I'm gonna pass in the my key pair file .pem. So the authenticity of the host cannot be established. Are you sure you want to continue connecting? Yes, I want to continue connecting. And now if you see, we have successfully SSH into our private server using our Bastion host. And this is how you will be able to communicate with a private EC2 instance if you want to from your Bastion host, and if you have no connections established to your private servers, right, you can use a Bastion host for that. Alright, I hope that makes sense. I'm gonna just close this right now, and let us go back to our slides and let us continue with NAT gateways. Now, what are NAT gateways actually? And it's a pretty interesting concept to know about NAT gateways. So it is a AWS managed NAT, okay, and with higher bandwidth, high availability, and no administration. So NAT stands for Network Address Translation. So what is a NAT gateway? Is basically, for example, you have a private EC2 instance, right, in your private subnet. Now this private EC2 instance, even though it will not accept any incoming connections, it needs to communicate with the outside world for some, for example, updates or patches or etc. Now you can argue with me that, okay, you just talked about Bastion host right now, why can't we do that using it? Yes, that is a good option, but the thing is, using a Bastion host at one time you can communicate with only one private instance, for example, and if you have like 1000 private instances, then it will be very difficult to manage. And another one thing is that if you do not want to keep any kind of communication, incoming communication even from the Bastion host to your private instance, then it is not possible for your private EC2 instances to communicate with the outside world. So that's where the NAT gateway comes into the picture. So you will associate a NAT gateway, right, and with your private subnet, right, so that your private EC2 instances will be able to communicate with the outside world, but it will not accept any incoming connections from the outside world. It can't be used by EC2 instance in the same subnet, only from other subnets, okay, and basically requires an internet gateway. So what will happen? The instances from your private subnet will communicate with your NAT gateway. The NAT gateway will in turn communicate with your internet gateway. So it's kind of this relation. So the NAT gateway, so it will know, the instance will know that, okay, I have a NAT gateway established over here. So if I want to, for example, pull in an update from the outside world, I'm going to communicate with the NAT gateway, and the NAT gateway will in turn communicate with the internet gateway, which is already there in our VPC. And it provides you with 5 gigabits of bandwidth with automatic scaling up to 45 gigabits. So it is very, very fast. So you don't have to worry about that. You don't have to worry about any security groups or anything, and you just have to create the NAT gateway and you are good to go. I hope that makes sense now. And also very important point, a NAT gateway is created in a specific availability zone. So if your particular instances are in a separate availability zone, it is not going to work. So keep that. If you are creating in, for example, a NAT gateway in US East 1A, then instances only in US East 1A will be able to communicate. And it uses an elastic IP, right, which is a fixed IP. Okay, so this is how the NAT gateway diagram looks like. So you will be having a private EC2 instance in your private subnet. You have to, obviously create a route if the private EC2 instance needs to communicate with the outside world. So basically you will create a route which says it has to go through the NAT gateway, which will be in your public subnet, and then the NAT gateway will in turn communicate with your internet gateway, and it will establish a route out to the internet. Okay, so it can feel a little bit complicated right now, but it is actually pretty simple. The thing is, anything that wants to go outside of a VPC needs to go through the internet gateway. That's fine, easy to understand. But you don't want your private EC2 instance to communicate with the NAT gateway, because you don't want any direct connection of the outside world with your private EC2 instance. So you are creating a NAT gateway which will be the only point of contact of your private EC2 instances to communicate with the outside world, and your NAT gateway will in turn communicate with your internet gateway, and it will have the route out to the internet. I hope that makes a lot of sense. Now let us go ahead and do a little bit of demo on this NAT gateway, and everything should be pretty much of clearer to you guys. Okay guys, now let us see how we can if I want to do some connect from this private server to the outside world or the public internet, how do I do that using NAT gateways, right? So if I go back to my VPC management console, I'm just gonna go to over here. Let me just search for NAT gateways over here. NAT gateways. Currently I do not have any NAT gateways. Let me remove this filter also. I'm gonna create a NAT gateway, and I'm gonna name this NAT gateway as my private NAT gateway, something like that. The subnet, you can for high availability you can deploy this NAT gateway in multiple public subnets. I mean, if for example this subnet has some issues, you can deploy it in another public subnet, right? So yeah, that you can do that. That's for high availability. So I'm gonna deploy it in the public subnet. Connectivity type is public, and I'm gonna allocate an elastic IP to it, right? Because it needs a fixed elastic IP. And in additional settings, you do not have to do anything, and you can just create the NAT gateway, and we are done, right? And it will take some time to create the NAT gateway, and while it is creating the NAT gateway, let us go to the route tables over here. Let us select the private routes. Now currently if we see the routes, then it is just a local route over here, but there is no route which says okay, if any IP address wants to like communicate to the outside world, then like how to do that. We do not have a route for that, right? Over here we just have a local route. So to create the route out to the internet for the private instances, like for example just for communicating to the outside world through the NAT gateway, we have to create a route over here to the NAT gateway. Now how do we do that? Just gonna click on edit routes, click on add routes, and I'm gonna select the destination as any IP. Target is for example, let's say the NAT gateway, and this is the NAT gateway that is available. So we're gonna select that, and we're gonna save the changes. So what will happen that now any IP which wants to communicate to the particular outside world, it will go through the NAT gateway through this particular route. I hope that makes sense. Now if I go back to the NAT gateway, I hope it is ready to be used. So it is still in pending state. So while it is so now it is available. Great. Now what I'll do is I'll just connect back my Bastion host with my private server, and then try to contact the outside world or the public internet. So I'm just gonna select my Bastion host and click on connect over here, and click on this connect button. So I'll connect to my Bastion host, and then from my Bastion host I'm gonna connect to my private EC2 instance, right? I hope that makes sense. Now let us run the same commands. Let us run this SSH EC2 user hyphen this one. We are using the key pair because already we have learned this, right? I hope there is nothing to explain right now about this thing. So I am inside my private EC2 instance. Now I'll clear the screen, and I'm just gonna run ping google.com. So now you see that my private EC2 instance, which is in the private subnet, it is able to communicate with google.com, which makes sense now, because now the traffic is going to the NAT gateway. From the NAT gateway it is going to the internet gateway, and from the internet gateway it is going to the outside world. And in simple words, if you want to understand what is happening, so if I just have to draw a very bad diagram to explain you, sorry, my diagrams are really bad. So basically this is your private instance. So if it wants to communicate to the outside world, it first goes to the NAT gateway, and from there it goes to the IGW internet gateway and to the public internet. So this is the flow. And to make this NAT gateway highly available, you can deploy it in multiple subnets. And we're going to see one slide on this particular concept, but so don't worry about it. So I hope this is clear to you guys. Now this is NAT gateway. Now this is NAT gateway with high availability that I was talking about. So NAT gateways are resilient within a single availability zone. So basically you can see this diagram and understand, right? So for example, if you have only one NAT gateway, and basically if there is some issue, so you can deploy multiple NAT gateways and multiple AZs for fault tolerance, which is possible. It will be a highly available architecture for your networks. And there is no cross AZ failover needed, because if an AZ goes down, it doesn't need NAT, right? Because if one availability zone goes down, then basically it doesn't need a NAT gateway altogether. Obviously it makes sense, right? So to make it highly available, just deploy it in multiple public subnets in multiple availability zones. That should be working fine for high availability. So what is the difference between NAT gateway and NAT instance actually? Now NAT instance is actually like the predecessor of NAT gateway. Before NAT gateway, we used to use NAT instances. It is nothing but an EC2 instance, and basically what will happen, you have your private instance, and it wants to communicate to the public internet, so it will go through the NAT instance to the public internet, right? Now nowadays what is happening, this NAT instance is being replaced by NAT gateways. So as it is a topic, it is not going to come in the exam, but still, as it is still a topic, we're just going to see the differences between NAT gateway and NAT instance. If by mistake 1 or 2 questions come in the exam, you will be able to answer them. Now for availability NAT gateways, you can create multiple NAT gateways for high availability in multiple subnets. For NAT instance, you have to use a script for failover, because you cannot use automatic failover. Even if the EC2 instances are in different availability zones, you cannot do automatic failover. Bandwidth is up to 45 GBs in NAT gateway, and in NAT instance it depends on the EC2 instance type, and it also makes a lot of sense, right? If you are creating a NAT instance using T2 micro instance, then its network throughput will be less, right? Obviously it depends on the instance family or the instance type, the network throughput of a EC2 instance, right? Maintenance, it is managed by AWS, but it will be managed by you in case of NAT instance. Supports public IPv4, obviously EC2 supports public IPv4, so it makes sense. Private IPv4 it supports. This also supports private IPv4, because whatever is the feature of EC2 instances, that is the feature of NAT instance. Security groups is not supported by NAT gateway, and it also makes a lot of sense, because you don't have to worry about security groups in NAT gateway, but as NAT instance is a EC2 instance, you have to worry about security groups. Use as a Bastion host, cannot use the NAT gateway as a Bastion host, because that is not a EC2 instance, but as the NAT instance is kind of like a Bastion host only, you can use it as a Bastion host. So yeah, that is the difference between NAT gateway and NAT instance. Not that much important, but still something to wriggle about in your mind, right? Alright, let us move on to security groups and NACLs. Now security groups and NACLs are kind of different, and the major difference between security groups and NACLs are, and I'm telling this from the start because it may strike your mind later on, NACLs are stateless and security groups are stateful. Just keep this in your mind like a fortune cookie or something like that, because it may come handy when I'm going to talk about statefulness and statelessness in the upcoming slides. Now the thing is, this is the basic diagram of like incoming and outgoing request, and you're going to understand why this is stateful and it's NACLs, which is network access control list, right? It stands for network access control lists, right? Now see, if there is if there is an incoming request, right, and for example what is happening, there are inbound rules in NACLs, like you create inbound rules in security groups, you have inbound rules in NACLs, right? So the request comes in, it checks if that particular traffic is allowed or not. If it is allowed, then it sends it back, sends it like inside, like it opens the door, but still there is this security group over here. Now this security group also has the permission like to accept or reject that particular traffic that is coming in. Even if the NACL allows it, it doesn't matter that the security group will allow it. So there should be an inbound rule for this traffic in the security group also. If this is allowed, then basically it will reach the EC2 instance, right? Now the funny thing is that if security group allows something, then by default outbound is also allowed. So the same traffic can go out of the security group without any issues. But when it comes to NACL, while the traffic is leaving the network, there will be outbound rules, and in the outbound rules it will check if this particular traffic is allowed out of the network or not. So if it is not allowed, then it will block it over here. If it is allowed, it will allow it over here. That is why it is stateless, because the security group kind of remembers like, okay, this particular traffic was allowed in, so I'm going to allow it out. But when it comes to network or NACLs, if there should be particular inbound rules and outbound rules. If it is not there, then basically the particular traffic will not be allowed in or allowed out. I hope that makes a lot of sense. That's a brain nugget for you guys to think about. Now it's the same thing as about an outgoing request, right? If the security groups allows something out of the security group, then it is by default allowed in. But that is not the case with NACL. If something is allowed out, the same may or may not be allowed in by using outbound or inbound rules, right? So that is why in security groups we usually define the inbound security rules, because if we define the inbound security rules, then by default it is allowed out. But when it comes to NACLs or network access control lists, we have to define both inbound and outbound rules because it is stateless. I hope now the difference between statelessness and statefulness is clear as crystal. Right? Now let us move on to the next topic. So a little bit of whatever I said in the last slide is basically what I am this written over here. NACL is like a firewall which control traffic from and to the subnets, right? Security group is for your EC2 instances and NACLs is for your subnets. That is very, very important to understand. And this rule, which is one NACL per subnet, one NACL per subnet. New subnets are assigned with the default NACL. So when we create subnets, a default NACL is automatically created. Now you can ask me a particular doubt that, okay, if a default NACL is created, then the default NACL is allowing everything in and out. Yes, that is correct. The default NACL by default is allowing everything in and out, right? But it is a good practice to not use the default NACL and create your own NACL, because when you create a new NACL, this default behavior which allows all the traffic in and out is not there. You have to create the inbound and outbound rules for that. And you define the NACL rules. Rules have a number 1 to 32,766, higher precedent with lower number. If there is a rule above a particular rule, like this rule, so this rule will override this rule. So remember that this has a higher precedence than this rule, right? So as lower the number as you go, the higher precedence it is. First rule will drive the decision. That's why I told you, right? If you have another rule like rule number 2, rule number 1 will override rule number 2. For an example, if you define at number 100 allow this IP address, and at 200 you say deny the same IP address, the IP address will be allowed because 100 has a higher precedence than 200. So it is overriding the 200 rule. I hope that is fine. The last rule is an asterisk and denies a request in case of no rule match. So basically, if you have denial requests, right, it is a very good principle to write it at the end with the star, because first of all your allow rules match. For example, if none of the rules match, then basically you just deny it. That's it. And AWS recommends adding rules by increment of 100. It becomes really readable if you increment, keep your rules at an incremental level of 100. Newly created NACLs will deny everything. That is why I told you that it is different from the default NACL, because when you create a new NACL for your subnet, it will automatically deny everything, but the default NACL by default allows everything. NACLs are a great way of blocking a specific IP address at the subnet level, and this is why do you say that, okay, I need to block NACL, why do we need to use NACL to block IP address? Why cannot I use security groups? Because see, IP addresses should be blocked at the subnet level, not at the EC2 instance level, because there can be thousands of EC2 instances in your particular subnet, for example. So will you go to the security group of each and every EC2 instance and deny it? No, right? You will write a rule in the network access control list that, okay, this IP address is not allowed inside my subnet, and then that particular inbound rule in your network access control list will block that particular IP address. I hope I'm making a lot of sense over here. So there is a question in the exam which comes like, if I need to block a particular IP address, should I use the NACL or should I use the security group? And the answer should be NACL every time. Okay. So this is how so as you can see now, our diagram is getting a little bit, like the first one that we saw. So now we have the internet gateway, we have our NAT gateway, we have the route table set in, we have the public and private subnets, and the next thing we're going to add are these NACLs for our subnets, and we're going to do it right now. We're going to add the NACLs into our subnets, right? I hope that makes sense now. So the default NACL, as I've already told you, that it accepts everything inbound and outbound with its subnets it's associated with. Do not modify the default NACL, instead create your own custom NACL. So I've already told you that default NACLs do not modify it, because leave it. You can modify it, but why will you do it? All thing that is default, I'm telling you, right? Everything that is default, do not change those things while you are doing something in AWS. Create your own stuff. It becomes much more easier to manage them. So in default NACL, you can see that there is a 100 rule which allows all IPv4 traffic, and the source is everything, so allow. So this rule actually overrides all other rules below, even though there is a deny rule with the asterisk sign. This 100 rule, which has a higher precedence, just overrides everything. Outbound rules also the same. This 100 rule just allows everything outside. So whatever you write after that will be overridden by this rule number 100 that you see over here. I hope that makes sense right now. All right. So let us talk about ephemeral ports and what are ephemeral ports. So for any two endpoints to establish a connection, they must use ports, right? Basically, yeah. So there is a client and there is a server, and what happens is that the client requests something on the server port, for example port 80 on the server. Now the server will respond back with some information, and the client should have any of the ports opened to receive that information, right? If the client doesn't have any open ports to receive that information from the server, then there will be the client will not be able to receive that response, right? And that port in the client side is known as ephemeral port. Simple. So different operating systems are use different port ranges. For example, INA and MS Windows use, like Windows 10 use 49,152 to 65,535, and for Linux kernels it is 32,768 to 60,999. It means that if you have a Windows machine like this, if it is a Windows machine, right, and if it wants to receive the response from this server, it can receive that response from any of these ports, like 49,154. That port is open on the client side, so it will receive the response. So that is what it means, right? So similarly, what is it? I hope that make things clear. That is why you see in this web server the fixed port is 443, but while the client receives the response, it is receiving on an ephemeral port which is 50,105. NACL with ephemeral ports. So basically, how do you use NACL to allow or block ephemeral ports? So this is the web tier, for example, and this is in the public subnet, and this is the database tier, which is in the private subnet. So you should have outbound TCP on port 3306 to DB subnet CIDR. It means that your the particular NACL associated with your public subnet must have outbound TCP rule on port 3306 to this particular subnet. If it doesn't have that outbound rule, then any outbound traffic for 3306, which is basically for the database, like a MySQL port, that 3306 is MySQL port. So if there is no outbound traffic over here, then it will not go out of this particular public subnet. So you should have that outbound rule in the public subnets NACL. Similarly, in the database tier, it should allow inbound TCP on port 3306 for this particular DB instance, right? So this particular NACL should have inbound rule over here, and this should have outbound rule for port 3306. I hope that makes sense. Now what will happen, this database here, this database will send some response back to the client, which is the web tier. So this particular this NACL associated with the private subnet should have outbound TCP on port number any of these ephemeral ports, because the response will be on the ephemeral ports, right? So that is why it should have an outbound TCP on any of the ephemeral ports, and this particular web tier must have inbound TCP on any of the ephemeral ports. Otherwise, the response will not get received by the web tier. Right? I hope that makes sense. I hope that makes a lot of sense to you guys. Alright, so create NACL rules for each target, as I've told you, right? So for this one, there should be like outbound and inbound rules, and for this one also, you can create outbound and inbound rules for your respective subnets, right? So that should make sense. Okay, now the thing is, you may ask a question, why is this NACL associated with two subnets? The rule is one NACL per subnet, but the vice versa is not true. It means that one NACL, I said the wrong thing. So one subnet, I said the right thing. Sorry, I'm getting confused. One NACL per subnet, that is true. So basically, a subnet should have one NACL, but one NACL can have multiple subnets. It means that one NACL can be associated with multiple subnets. That's what I meant to say. So that is why one NACL, if you see, they can be associated with multiple subnets. I hope that makes a lot of sense. Okay, so let us move on to security group versus NACLs. So basically, you know, right, as I've already told you from the start, that security groups are stateful and NACLs are stateless. So stateless, and this is stateful. And basically, this is the firewall for your EC2 instances, and this is the firewall for your subnets. I think that is enough, information to go on and work with NACLs and security group, right? So basically, security group, there is no like evaluation order. All rules are evaluated before deciding whether to allow traffic. But in NACL, it is evaluated in a priority, like lower priority or rules have higher priority. Sorry, lower numbered rules have higher priority, right? And that is what is followed in NACLs, but in security group it is not the case, right? I hope that makes sense. Okay, so before going to VPC peering, let us see some examples about this security groups. So let me go back to here. Let me go back to my VPCs and let me go to network ACLs. And over here I have there is two network ACLs actually. One is associated with my default VPC, and another one is associated with my prod VPC. This is with this one. So let me just filter for my prod VPC, and if you see over here, okay, it's not getting filtered. Okay, whatever. So let me just click on this prod VPC NACL or subnets NACL. So because one NACL was created and it was allocated to both of the subnets. And if you see the inbound rules, you can see that rule number 100 allows everything. And similarly for the outbound rules, rule number 100 allows everything outside of to go outside of the particular subnet. So if you write any deny rule below this particular allow rule, it will not work at all. And I've already told you that you please do not play around with the default NACL. It is better to create your own NACL and play around with it. So what I'm going to do now is I'm going to go to actions, and I'm going to edit subnet associations, and I'm going to do is I'm going to try to remove, okay, cannot dissociate this thing, okay, whatever. So what I'm going to do now is I'm going to just go to NACLs. Where is the NACLs? Network NACLs, and I'm going to create a network NACL over here. Create a network NACL, and I'm going to name this NACL as public subnet NACL. and I'm going to choose a VPC which is my prod VPC, okay, this one, and I'm going to create this network NACL. So currently I have 3 network NACLs. I'm gonna go inside this public network NACL, and I'm gonna go to actions, and I'm gonna say edit subnet associations, and I'm gonna select this public subnet because I want to associate this particular NACL with my public subnet, right? I'm gonna select that and I'm gonna say save the changes. So now this network NACL is associated with my public subnet, and you can see by default it is not allowing any traffic, and in the outbound rule also by default it is not allowing to any traffic to go outside. So this, if you see the subnet association, this is associated with the public subnet, and currently if I go, this instance that I have, this Bastion host is actually in my public subnet. So now if I select this Bastion host, and if I try to connect to my Bastion host over here and click on connect, let's see what happens. So it says failed to connect to your instance, and what is the reason for that? The reason is pretty simple, guys. The reason is pretty simple. So my Bastion host is in the public subnet, right? So this is my public subnet. Let me just full screen a little bit. This is my public subnet, right? Public subnet, and inside it there is my Bastion host or my server, or Bastion host. This is my EC2 instance, and surrounding that EC2 instance is my security group. Now the thing is, I created an NACL which was public network NACL, and it doesn't allow any traffic. It's like a complete blocker, because when you create a new NACL, it by default it blocks everything. Even though my security group is allowing SSH connections, my NACL is blocking all the SSH connections. Not only SSH connections, actually not allowing anything. So I need to create an inbound rule in my particular NACL first to allow the SSH connections. Then only the particular traffic will pass through the NACL, and then it will go and check if the security group allows it or not. So it's like a 2-step process. Now let us go to this here, and let me go to inbound rules, and there is a explicit deny rule. I'm gonna say edit inbound rules, and I'm gonna add a new rule. Let's add it 100, and I'm gonna say SSH port number 22, and the source is from anywhere, and it is the allow. Okay, and let us save the changes. So now I have this, if I go to this network NACL and if I check this inbound rule, I have a lower order rule which allows SSH traffic into my instance, and then I have a star rule which deny the SSH traffic. So if I go back and if I try to connect to my instance again, okay, it still says failed. I think it will take some time to take effect. So this is my public subnet NACL, and I hope the subnet associations are good with it. Inbound rules allow the traffic on this thing, and if I go, let me try to connect it again. Okay, so I think I can understand what is the issue in this case. The thing is, if you see this diagram, we have allowed SSH connections into our NACL, right? We have allowed EC2 connections into our NACL, sorry, SSH connections into our subnet. But what about the response? So when it is reaching the Bastion host, but when the Bastion host is trying to respond back, I am the client who is requesting for the SSH access, right? When the Bastion host is actually trying to respond back to my SSH connection request, it is not being able to do it because there is no outbound rule in the NACL which allows it. Because we have this practice of working with security group, we just define the inbound rules and we forget about the outbound rules, because by default the outbound is also allowed, but it is not the case with NACLs. We have to create a outbound rule in this case. So let me go back, let me go over here and let me click on outbound rules and let us edit the outbound rules. Okay, so I'm gonna add a rule over here, add a new rule, and let's say the rule number is 100, and I'm gonna just say all traffic, and the destination is 0.0.0.0/0. So I'm saying that allow any traffic out of my subnet. That's what I'm saying. And then I'm gonna save the changes. Okay, so I hope this makes sense now. So I have a lower order rule which has a higher priority, which allows any traffic out of my subnet, right? Now let me go back over here. Let me click on connect now. Now you can see that the connections is working. So yeah, when you work with networking this at this level, like network ACL security groups, you have to make sure that okay, like there are two levels of access to my EC2 instance. One is my security group and then my network ACL. So whenever you find this connection refused request, first check your security groups if it has that particular inbound rule or not, and then check your network ACLs. So to see if my rule ordering is working or not, I'm gonna go over this NACL and I'm gonna click on this edit inbound rules. I'm gonna add another rule 200 which denies SSH. So I'm gonna save the changes. So see, I have a higher order rule which allows SSH, and then I have a lower order rule which says lower priority rule. So don't get confused. Lower order means that higher priority, higher order means lower priority. That's the difference. So I have a high priority rule which says allow SSH, and a low priority rule which says deny SSH. So if I go back and try to connect to my EC2 instance over here, then let's see what happens over in this case. I'm able to connect to it. It's not blocking the rule because it makes no sense, because this particular rule is overridden, right? Okay, so I'm gonna just delete this rule because it is not required. I don't want to keep unnecessary changes. So yeah, that's all about security groups and NACLs, guys. I hope this was a good really difference between security groups and NACLs. And if you wanna work around with your security groups, then you can go over here, and we have this public EC2 SD security group. And if I go inside this security group and in the inbound rules, if I edit inbound rules and delete this inbound rule for this particular SSH connection, even though my NACL allows it, my security group will not allow it because I will delete this rule, right? So you can try and play around with security groups and NACLs as much as you like. And that's all about NACLs and security groups. So guys, let us talk about VPC peering. All right, so basically what is VPC peering is, you have one VPC. So for example, this is VPC A, and you have another VPC, this is VPC B, and there is one EC2 instance over here, and there is one EC2 instance over here, and you want both of these EC2 instances to be talking to each other over the private network, not using the public IP, because using the public IP you can do it, but using the private network. So what you're gonna do is you're gonna establish a peering connection between these two VPCs, right? So basically, whenever your requirement is basically to connect two VPCs, you're gonna connect them using a peering connection. And remember, very important thing, they must not have overlapping CIDRs. It means that if this has a 10.0.0.0/16, then it cannot have a 10.0.0.0/16. Though these two CIDRs are overlapping. This particular VPC can have like 172.16.0 or something like that. right? So they shouldn't have overlapping CIDRs. VPC peering connection is not transitive, must be established for each VPC that needs to communicate with one another. So what is this thing? If you have a VPC A and you have established a connection with VPC B, so these two are peered, then VPC B is peered with VPC C. So it doesn't mean that the traffic, if it is want to reach to from A to C, then it cannot go through B, something like that. It is not transitive like this. If your traffic needs to reach from A to C, you have to create another peer from A to C itself. You must update route tables in each VPC subnets to ensure EC2 instances can communicate with each other. So basically what you mean that if there is a, for example, EC2 instance over here and there is a EC2 instance over here, so you have established the peering connection, that is all right, but the thing is still there is no route to this peering connection from here to here. So to establish a route in a route table, like the destination must be the CIDR of this particular VPC in the route table of VPC A, and you have to do it over here also. Destination of this route table from here should be the CIDR of VPC A, right? So you have to update the route table of both this VPC A and VPC B so that there will be communication between these two VPCs. I hope that makes things clear. So good to know. You can create VPC peering connection between VPCs in different AWS accounts or regions. Very good thing to know that even if you have a VPC in a different AWS account, you can create a peering connection. And if you create a peering connection, then the respective VPC that is in a different account, the owner must have to accept the peering connection, otherwise it will not get established. And I'm going to show you that in a minute. Don't worry about it. You can reference a security group in a peered VPC. So if a VPC and VPC B are peered and there is a security group in VPC B, you can reference it from the VPC A. That's what I mean, right? Hope that is clear. So basically if you're gonna see, if you will, for example, you have two more VPCs here and there, you can create peering connections between those VPCs to your own VPC. So this is our own VPC, which is the prod VPC, right? So you can do that. Alright, let us talk about this. Let us see a small demo on VPC peering. Not gonna do a very big demo because it will be a little bit complicated and don't want to make this entire lecture complicated. Let us see a way in which we can establish a peering connection, right? So if I go back and if I go to my VPCs, I currently have two VPCs, and let me just rename this to default VPC, right? So that I can distinguish between these things. So you can see the IPv4 CIDR of this default VPC is 172.31.0.0/16 and this is 10.0.0.0/16. So both are not overlapping, so both can be peered, right? So let us see how we can create a peering connection. I want to create a peering connection from this prod VPC to this default VPC, right? That's what I mean. So I'm gonna go to where is it? Transit gateways, firewalls. I think it should be somewhere around, yeah, here it is, peering connections. So here we do not have any peering connections. So I'm going to create a peering connection, and in this peering connection I'm going to name this peering connection is my prod peer connection. Select a local VPC to peer with. For example, this is the requester VPC. So if you wanna, for example, VPC A is going to be paired with VPC C, so the source is VPC A. So you have to select that. In this case, the source is prod VPC. So I'm gonna select that. It has a CIDR of 10.0.0.0/16. Hope it makes sense. Then we have to select another VPC to peer with, and it is in my account. If it is in a different account, you have to select the key, give the account ID and then provide the VPC, but it is in my account, so I'm going to select my account over here, and it is also in this region. It can also be across region also, but in this case it is in the same region. And VPC ID, the acceptor, is the default VPC, so I'm just gonna select that, and you can see that both of these CIDR ranges are not overlapping. I'm saying this again and again so that it will stick to your mind. Great. Now what I'm going to do is I'm going to create this peering connection, and it says pending acceptance. You can accept or reject this peering connection. See, the thing is, I've told you, right, if one VPC is trying to peer with another VPC, so the accepting VPC must accept that connection. and if it is in a different account, in that case the account owner of that particular account has to accept the peering connection. In this case it's the same account, so I'm just gonna go over here and accept the connection, accept request. Now it is done, right? Has been established, it says. Now it says modify my route tables, but let us see. So both of my VPCs have established the connection, right? Now let us see an instance. I'm not going to create that instance, but let us see a scenario where you have to update the route table, right? So this is my prod VPC. So this is my, let me just go back and see. Okay, so this is my prod VPC. This is my default VPC, right? There is a EC2 instance in my prod VPC, which is the Bastion host, and there is a default in the default VPC. For example, there is, currently I don't have it, but imagine I have an instance and it is known as, for example, private server. I want this particular Bastion host to communicate with my private server, right? And we have established a peering connection between these two VPC. So these are a peering connection established. So can these instances now communicate with each other? The answer is no. Why? Because in the route table, this is the route table of the prod VPC, there is no route. If this Bastion host says, okay, I want to communicate, okay, this has a CIDR of 10.0.0.0/16 and this has a CIDR of 72.31.0.0/16. So if this Bastion host says, okay, I want to send the traffic to 172.31.0.0, which is a peered connection, then this route table doesn't have any routes. So we have to create a route so that if any traffic goes and it checks in the route table, okay, if I want to go to this particular route, then it finds the route there and the traffic is then sent over here. Now the similar thing, just the opposite. The private server, which is in the default VPC, must also establish a route in its route table to this prod VPC, right? If it checks, okay, a route exists to the prod VPC, then I'm gonna then send the traffic to this prod VPC. So route tables and both of these VPC must update itself. You have to update it, it's not gonna do automatically. You have to update it so that they can communicate with each other over the peered connection. So you should keep in mind, in the exam, if there is a question, what are the steps of the peering connection, then you have to include this route table steps also. Hope that makes sense. Now let me give you an example of updating the route table. I'm gonna go to my prod VPC and select this and go to route tables, and I'm gonna just select the VPC, which is my prod VPC. So I should be seeing the route tables of here. So if I, for example, I want to update the public route table, I'm going to go over here, I'm going to go to the routes and I'm going to edit the routes. I'm going to add a route and this will be 172, the destination will be 172.0.0.0/16, and the target is what? That will be my peered connection. So I have to select that peered connection, and this is my peering connection. What will happen for this CIDR, because this CIDR is different from 10.0.0.0. So for a different CIDR, which is a private CIDR, it will look for that particular peered connection. If it is not there, then you cannot create this route in this table, right? So you create this and the target is that peering connection, and then just save the changes. Okay, and the same thing you have to do it with the default VPC. You have to go to the default VPC and let me go to the route tables. So we have only one route table. In this case, you have to update the route and include that particular 10.0.0.0 route in this route table of this default VPC, so that in the end, after updating the route table, if you create an EC2 instance or some other device in that network, they will be able to communicate with each other. I hope that makes sense. So yeah, that's how you work with peering connections, guys, and I hope you understood what are peering connections and all, and pretty cool stuff, right? how you can, like, you have a network in a one region, you can peer with another network in another region, and even if peering happens cross account also, which is a very, very good thing, right? All right, let us move on to the next topic, and let us talk about this topic, which is types of endpoints. Now, what are endpoints actually? Let us talk about that. So if there is a EC2 instance, for example, in your subnet, it's a private subnet, it wants to access S3 service. This access must be over the public internet. That is the only way, because you cannot deploy a S3 bucket in your VPC, right? It is not possible. The different in case of RDS and other managed services, it is possible, but in case of like serverless services like S3, it is not possible to deploy it in the same subnet. So you have to go through the public internet, and when you go through the public internet, you will face some data transfer charges, obviously. Is there a way so that you will be able to access the S3 bucket or DynamoDB database or something like that over the private internet? It is possible with the help of endpoints. And there are two types of endpoints generally. One is known as interface endpoints, another one is known as gateway endpoints. Now, interface endpoints are kind of a little bit on the costlier side, because it provides you to access any service. Actually, it says most of AWS services, but actually it will give you access to any kind of service that you need, and you can access it using the private network. Why? Because it provides provisions a ENI, which is an elastic network interface, as an entry point, and you have to attach a security group to it. That's why it supports most of the services, and you have to pay per hour in dollars and per GB of data processed. So interface endpoints, if there is a requirement, for example, to communicate with SNS or SQS, you have to use interface endpoints, because gateway endpoints do not support that. So what are gateway endpoints actually? Gateway endpoints are free. It will give you private access to those services, but to limited services. And what are the services that gateway endpoints provide access to? It is only S3 and DynamoDB. It is only S3 and DynamoDB. So basically, if your application, which is in your private network, wants to communicate with S3 and DynamoDB only, then you should go over gateway endpoints. It is not that the interface endpoints cannot connect with the S3 and DynamoDB, but it will cost you. On the other hand, gateway endpoints will provide you free of cost access in a private manner, right? So why will you go to interface endpoints? And what does it does? It does provides a gateway and must be used as a target in the route table, does not use a security group. So there is nothing, that you have to, like any kind of security group, you don't have to create anything. You just specify the gateway as a target in your route table, for example, from this particular subnet, and then it will get connected, and it is free of cost. So in the exam, whenever you see like if you have a choice between interface endpoints and gateway endpoints, please go with gateway endpoints, right? Because they are free. But in some cases where, for example, if the question says that you have to communicate with SNS or SQS or some other service other than S3 and DynamoDB, you have to go with interface endpoints, even if they cost you a little bit more. So I hope I have given you enough suggestions about interface endpoint for S3. Gateway is most likely going to be the preferred all the time in the exam for S3 and DynamoDB, right? Lambda in VPC accessing DynamoDB. Now you can create Lambda in VPC first of all, and we have covered this actually a little bit in our serverless lecture. You can go and see the serverless lecture. It is up in my channel in my playlist. You can go and watch it. So DynamoDB is a public service, right? Obviously, and if you want to communicate with DynamoDB, or the way is to use the gateway endpoint, right? So how will your Lambda in your VPC access the DynamoDB? Option 1 is basically access from the public internet. That is the general way, right? You can access any service of AWS through the public internet. Option 2 is better and free, that is access from a private network. Deploy a VPC gateway endpoint. That's it. So That's the thing. If there is DynamoDB and S3 and you need to access it through a private network or through a endpoint like private VPC network, then basically the option should always be the gateway endpoint, not the interface endpoint. Even if in Lambda cases also it holds true. Okay, VPC Flow Logs, guys, and as the name suggests, these are logs for your network. So capture log information about IP traffic going into your interfaces and out of your interfaces. So basically we have like these type of logs. One is VPC flow logs, subnet flow logs, like what traffic are going inside and outside of your subnets, and then we have elastic network interface ENI flow logs. Okay, just a minute. ENI flow logs. So it helps to monitor and troubleshoot connectivity issues, guys. I mean, for example, there is a VPC and there is a peering connection between VPC and VPC B, and for some reason you are seeing that the packets are, you know, the some kind of data loss is happening, right, while the data is transferred from VPC A to VPC B. Then you can inspect the VPC flow logs that is coming into your subnet in your VPC B, and you can check, okay, there is some issues over here. You can check the source address, you can check the destination address. Is the right data coming from the correct source or not? Because sometimes hacker may come in between and manipulate the data, right? So by the use of VPC flow log, you will be clearly able to see, okay, this is the source and this is the destination. I'm going to give you an example in a minute, so don't worry. So you can see how the logs actually are shown in the VPC flow log. So don't worry about it. So this is what VPC flow logs are, and you can store the data in S3, and also you can, you know, store it in CloudWatch logs, and you can run queries also, because you can run queries in CloudWatch logs based on some metrics, not metrics, actually parameters or something like that. So it captures network information from AWS managed interfaces too, like ELB, RDS, Elastic Cache, Redshift, Workspaces, NAT Gateway and Transit Gateway. Okay, very useful thing. So the diagram, if you see, so basically the VPC flow logs are like placed over here. If you know, you can just check the VPC flow logs, like what traffic goes in and out of your VPC, and you can store, for example, transfer it to CloudWatch, transfer it to S3, and you can do whatever you want. All right, hope that makes sense. So this is the syntax or how the particular VPC flow logs look like. So here you see a lot of data over here. So this is the version, this is 2 in over here. Then we have the interface ID, sorry, we have the account ID over here, like from which account it comes in. Then we have the interface ID, which is the ENI, right? For example, one EC2 instance is communicating with another EC2 instance. This has a ENI network interface and this has a ENI. We'll be able to see which ENI is communicating to which ENI using this interface ID. This is the source address, this is the destination address. This is the source port, this one, and this is the destination port. So 22, it means that someone is trying SSH connection, right? Something like that. The packets protocol here, then the bytes, number of bytes, what that is coming in, the start and the end, and then the accept, like, sorry, the action, which says either accept or reject that packet, something like that. So here are some other descriptions, like if you see the source, as I've already told you, if you see the source address and destination address of a VPC flow log, you'll be able to identify some problematic IP, like some hacker is trying to access or not. Source port and destination port action, if you see it's a success or failure of that particular data transfer or something. You can run queries and stuff in CloudWatch logs. You can even, after your you know, analysis, you can even create a dashboard in, for example, in what is that service, like it is, I forgot that service name for some reason. It's a interactive dashboard. I forgot that. No issues. Query VPC flow logs using Athena on S3 or CloudWatch log insights, right? You can actually, using Athena, you will be able to directly query on S3, right? So I hope you have understood about VPC flow logs. So this is a scenario where you know, troubleshoot security group and NACL issues. You have to look at the action field. We saw this action field over here, right? like what is the action, is it rejected or is it accepted? So that is the action field. You have to look at the action field. For incoming request, you see, okay, inbound reject. If the inbound is rejected, so for example some HTTP traffic is coming into your subnet and it is rejected, so you may check the NACL, because there may not be a inbound rule which accepts that request or that traffic. Or if the NACL has the inbound rule, okay, that is fine. Maybe the SG has an inbound rule which doesn't access it. It has a deny inbound rule, or it doesn't have a rule for accepting HTTP traffic, right? But if inbound is accepting, outbound is rejecting, so there is a problem with the NACL only. Why? Because NACL is stateless. So if inbound is accepting, then it means that in the case of security group, outside is also accepting, right? Outbound traffic is also, it will allow. So you don't have to check the security group anymore. You just have to check the NACL, right? When we talk about outgoing request, if there is a outbound reject, so from your EC2 instance, some traffic is going outside, that is a reject. You can check if there is some problems with the NACL outbound rules or the security group rules. Outbound is accepting but inbound is rejecting, then there is something wrong with the NACL. Remember, every time if there is a accept and a reject, inbound accept or outbound reject, then the problem obviously rise with the NACL, because if there is one accept, right, then the security group will allow the other accept also. But the NACL is not the case because it's stateless, right? So I hope you can use this technique to figure out any question in the exam. If it is alternate, outbound accept, inbound reject, or inbound accept, outbound reject, then basically something wrong with only the NACL only. Don't have to check the security group. But if there is one way accept or reject, for example, inbound reject altogether, then security group or NACL. I hope that makes sense now. Alright, let us move on to the next slide. And some common architecture of VPC flow logs. So you take the VPC flow logs, transfer it to CloudWatch logs and run some queries, and for example enable CloudWatch contributor insights. Contributor insights is a very, very important feature of CloudWatch. You can find out a lot of data, identifiable data, for example like top 10 IP addresses which are trying to access your resource or something like that. You take the VPC flow logs, go into CloudWatch logs, and if there is some kind of other traffic coming in, for example, that you don't know about, then you can raise a CloudWatch alarm and you can alert, send a notification like some kind of other traffic is kind of accessing your resource. So you can create a SNS notification for that also. Another architecture is like VPC flow logs go to S3 bucket. S3 bucket can directly query using Amazon Athena, like you can run SQL queries actually using Amazon Athena directly on S3, and that is one of the favorite questions that comes in the solutions architect exam. Like if you have some data in S3 and you want to run queries directly on S3 without taking the data out, what will you do? You have to run Amazon Athena queries on that. And here, okay, actually this is the service name that I forgot, which is used to generate interactive dashboards. It's actually a BI tool, and that is known as Amazon QuickSight. It just got out of my mind, just slipped out of my mind. So you can just take the Athena analysis and you can create dashboards, interactive charts, pie charts, bar charts, whatever you want in Amazon QuickSight. I hope that make a lot of sense. Let us move on. Now the only thing remaining in this VPC chapter is type of connections between your on-premises server to your VPC in the AWS cloud. And there are actually a couple of ways how you can establish the connection between your corporate data center and your Amazon VPC. One of those solution is a site-to-site VPN. So what you do is that you have your VPN gateway, like it's different from the internet gateway. Don't take it as an internet gateway. It is a VPN gateway for if you want to connect with another, for example, network outside of the AWS network, then you must have a VPN gateway over there. And on the customer side or the corporate data center, you must have a customer gateway. So these two are in place, right? The VPN gateway and then the customer gateway. Then you can create a site-to-site VPN connection, right? A virtual private network, right? Now basically what will happen, a VPN connection, I don't have to explain about a VPN connection, right? So basically it will create a tunnel, and using that tunnel you can securely transfer data through the tunnel, but obviously it will be over the public internet. So yeah, that's how the site-to-site VPN work. You create a VPN connection between a corporate data center and your VPN gateway. Now one question comes in the exam and it may confuse you. If you want to communicate with one VPC to another VPC in this, like two VPCs only which are on the AWS cloud, even though they are in different accounts, you can create a peering connection between them, but you cannot peer a corporate data center with your particular VPC, right? You have to like create like a site-to-site VPN connection or a direct connection, so you must be knowing that at all times. Okay, so this is the site-to-site VPN. The other way to connect is direct connect or DX, and it is actually the most expensive type of connection, I would say, because it provides a dedicated private connection from remote network to your VPC. It's kind of like a optical fiber connection between your corporate data center to your VPC, and it is the fastest and most expensive way of communicating between your networks. You have to set up a virtual private gateway on your VPC. You have to do that obviously, because if any traffic has to be connected to the corporate data center, you must have a virtual private gateway in your VPC. And you will be able to access public resources S3 and private EC2 on the same connection from the corporate data center. Use cases are increased bandwidth throughput, working with large data sets, and lower cost. Now lower cost comes in when you have tons and tons of data and you actually communicate from your corporate data center to the VPC like every day, every hour, because establishing the connection itself is very expensive and it takes a lot of days. It takes about 30 days to establish a direct connection between your corporate data center to your AWS VPC, and there are certain constraints also. Constraint is that there must be a AWS center nearby or a partner nearby. So AWS partners are just, you know, kind of brokers for AWS, like I don't know, not actually brokers, they are like partners, like they can facilitate certain AWS services to their customers, something like that. So there are certain constraints also. So when the exam, when it comes to the speed of connection, direct connect is not always the answer. Make sure you remember that. Direct connection is the answer when the customer doesn't care about the time for the connection or the expense of the connection. Okay, that should make a lot of sense. So connection types of direct connect, we have a dedicated connection and we have a hosted connection. So dedicated connections are physical Ethernet port dedicated to a customer and request made to AWS first, then completed by AWS direct connect partners. So it provides you up to 100 GBs of capacity. It means that the throughput or the bandwidth will be up to 100 gigabytes per second. When we talk about hosted connection, the maximum throughput that you get, that is 10 gigabytes per second, gigabits per second, not bytes, it's a small b. It is being done by direct connect partners, as I've told you, right? Because AWS also have partners. Okay, if there is a direct connect partner, then you can take a hosted connection, and if there is a AWS like direct facility there, then you can take a dedicated connection. There is a difference between both of them. Capacity can be added or removed on demand. You can get 1 to 5, 10 gigabits available at select AWS direct connect partners. Lead times are often longer than 1 month, as I've told you, to establish a new connection. So these things you need to remember, guys. Okay. All right, that should make a lot of sense. And this is a very cool feature, right? Let me just discard. I think this is the last slide. Okay. Now the thing is, for example, you have a corporate environment and you have connected to the VPC using a direct connect, and that is a primary connection. For some reason, it may be the case that this direct connect is down, so you should have a backup for that. And always in the exam, if there is an option that you should have 2 direct connects from your VPC to the corporate, then that is not the answer actually. It is possible, but it is very expensive. Instead of that, I mean, if the direct connect is down, then obviously AWS will try their best to fix it as soon as possible. I mean, the SLAs will be maximum like 1 day or something. So meanwhile, you can do your job using a site-to-site VPN connection, which will be much cheaper than establishing another direct connection. So this is backup question, comes in the exam a lot, so I thought of keeping this as in the lecture. Alright guys, I hope you guys understood this VPN lecture. I know this is a very massive lecture, but guys, I hope I have covered all of the topics which are very important when it comes to networking on AWS, guys. And I hope you liked the video, and yeah, I'm gonna meet you in the next video. Till then, have a nice day, take care, and bye bye.